Okay, geometry people, this is going to be a new format about trapezoids. So, let's start off with what is the definition. A trapezoid is a quadrilateral. It is not a parallelogram, so it's going to be a new branch in our flowchart. So we had parallelograms over here. Now we're going to have trapezoids over here. So trapezoids definition is a quadrilateral where only one set of sides are parallel, okay? So some of the notation in a trapezoid, you have two bases. So we're going to call this shorter one up here base 1. Down here we're going to call this base 2. And the sides we refer to as the legs of a trapezoid. Now because we have two different bases, you have two different sets of what we call base angles. So the base angles coming off of base 2 those are base angles for base 2, and then I also will have a set of base angles coming off of base 1. So these two are the base angles for base 1. Okay? So let's look at some other properties. A trapezoid in and of itself isn't very interesting until you turn it into an isosceles trapezoid. So just like an isosceles triangle, an isosceles trapezoid has congruent legs. So what that does, and that would be the definition of an isosceles trapezoid, a trapezoid that has congruent legs. What it does, just like in a triangle, is it makes the base angles congruent. So this angle is congruent to this. Those are the angles off of base 2. And off of base 1, these two angles will be congruent to each other as well. And also realize that because you have a parallelogram, or I'm sorry, not a parallelogram, but because you have this set of parallel sides, these angles will be supplementary. Okay? And another property that they don't mention in your book, but it is true, are that in an isosceles trapezoid only, not a regular trapezoid, but in an isosceles trapezoid, the diagonals are congruent. And we may do a little proof of that later on. Okay, so you have an isosceles trapezoid, legs are congruent, base angles off of each leg are congruent, and the consecutive angles here are going to be, because they're same side interior, will be supplementary. Diagonals are congruent. Another part of a trapezoid that we have is called the median, or I prefer the mid-segment. Some books will actually refer to it as a mid-segment. It is the segment that connects the midpoint of the two sides. So this would be midpoint M, this will be midpoint N. So remember, I have base 1, I now have a median here, and I have base 2. And the relationship you have here is that the median is half the sum of the bases. It is the average. So what that means in terms of algebra is you have the median equals 1/2 the sum of base 1 plus base 2. So that's what it means to take an average of two things. So if we did a little example here, if I had base 1 is x minus 3, and I had base 2 was 2x minus 4, and I knew that my median were 10, I could solve for x. So I would let 10 equal 1/2 x minus 3, sorry, still learning this program, plus 2x minus 4. So combining our like terms, we have 10 equals 1/2. So this will be 3x minus 7. Now I did this on purpose. Notice we sometimes would distribute that too, but because everything inside the parentheses is odd, I think a better way to go would be to multiply both sides by 2. So I'm going to multiply this side by 2 and multiply the 10 by 2 so that we end up with 20 equals 3x minus 7. So you have 27 equals 3x, and from there we know that gives us x equals 9. Okay? So you're basically taking the average. This will be a halfway point between these two bases. Another example I'm going to try and squeeze on in this same diagram is, what if I knew that this was 12 and I knew that my median was 25, but I didn't know what base 2 was? Well, rather than using the whole formula, this is like those midpoint problems where you know the midpoint but not the other endpoint. So don't bother going through some big formula, just reason out that this is a halfway point. So from 12 to 25, that means you went up by 13, so to get to the other base you have to go up by the same amount since this is halfway. So 25 plus 13 is going to give you 38. And you could double check, yes, 38 plus 12 is 50 and half of 50 is 25. Okay, so we've taken a look now at trapezoid. Reminder, so for our quadrilateral, sorry that my diagram did not quite fit in the box, we had parallelograms where here's a summary of all our properties, and now what we're going to do is we are going to create a new branch, and we're going to show it in the next side. So coming off over here, we're going to have our trapezoids. And the definition again of a trapezoid is that you have, and again it's under the quadrilateral title, so we know it's a quadrilateral with one set of parallel sides. More interestingly though is underneath a trapezoid you have isosceles trapezoids, and that is a trapezoid with two congruent legs, and then you have the properties of base angles congruent and the diagonals being congruent. Okay? So I hope you're out having a happy Halloween or about to go out and have a happy Halloween and got a quick look at this.